Alright, so figured that we should go over and do a quick walkthrough of the practice problem that we have for quiz 4. So this is the first one that's there, so this is part of the base one. I've also got a video that's going to come out that covers the practice problem for the quiz 4B as well. So for this one, it is going to cover content up through the loft feature. So that means that there is a potential that the loft could show up on the quiz. We've also got some of the standard ones that we've already had. So we've got a sweep that could be useful. We've got linear patterns and a circular pattern as well. Yeah, so we see we've got these little cutouts on the lip of our little mug as well. And then all the other stuff and all the other tools that we've covered in the course so far could also show up. So for this one, we do see that we have a hollowed out portion of our object. And actually, let's make our lives a little easier with our snip tool. This way we can scribble on it. So get us a quick picture there. There we go. And we've got, yep, there we go. So we do see that we have some hollowed aspects of our geometry, and we've got a little note down here specifying a wall thickness of 0.2. That's a pretty dead ringer that we've got some kind of shell feature going on. And if there's a shell, that means that there needs to be some features that are created before the shell, and then some features that are created afterwards. So in this case, we do have some uh, main sort of hollowed area based on our hidden lines. We see that the main mug body is all hollowed out. And taking a look at our pictorial and our views, it looks like that main body is going to be a loft. So we've got sort of a hexagon on the bottom and a circle on the top, and then we've got these curved faces that sort of smoothly connect between them. That's the hollowed out portion. Then we've got these little notches around the rim of the cup. Looks like there are 7 of them based on our note. And then we have a handle sprouting off the side. This looks like it would be a pretty easy sweep feature, just because we've got sort of the same profile or a consistent diameter of 0.4 profile that follows through that entire shape. And then we've got a couple little notches carved into the top of it as well. So that we can probably do a linear pattern. Once we've got one of them, pattern to get the rest. Cool. So, gives us a bit of a plane of attack. Let's get a new file open. This one is going to be in inch units, so we make sure that we set our IPS at the start. Then, let's think about how to create that loft feature. So lofts generally require at least 2 profiles, and anything that would be on the quiz would be a rather simple loft application, since it's one of the most recent tools that you will have learned at this point. And in this case, we've got the hexagon at the bottom, the circle on the top. No fanciness going on, no guide curves, no extra things, no starter end conditions. So all in all, pretty straightforward. And for that, we're going to need to begin with a sketch. So let's do the hexagon first. So we'll start with the bottom. Makes sense. And that is visible on the bottom view down here. So we have that bottom view, and from there, we can see that we've got our hexagon drawn out nice and easy. So we'll open up our polygon tool, because drawing a hexagon by hand is awful. And for this, we've got 6 sides, well, a regular hexagon by hand. Drawing a hexagon's easy. Drawing a hexagon that looks good, that's where it gets more of a pain. So that gives us a shape to work with, but it can still rotate freely, and we don't have anything for its size. Size is easy enough. We have a 4-dimension specifying that the distance from the top edge to the bottom edge is 4 units. Now to get its orientation down, we can see that we've sort of got one straight edge on the top of our object, so I'll just grab one of these, set it to horizontal, and that gets us fully defined. Exit sketch. Now we need our circle, and the circle is going to be drawn on an offset plane 5 units up. So we're going to need to begin by creating a new reference plane that is up from the top plane 5 units. Checkmark. Now we can create a new sketch on this reference plane, and that's going to be our circle with a diameter of 4.6. Cool. Do be very careful about making sure that you are using your dimensions, because it does look like it goes right through the corner, but if we zoom in a little bit on our sketch, we see that the corner ends up going slightly past it. So in reality, it's not going to be as nice and neat as it looks like it could be in the drawing. But now that we've got our dimension, we're not quite done yet. The loft feature works best if the profiles have the same number of edges. So for our hexagon, that one's got our 6 edges down at the bottom, but our circle currently only has a single edge going around the entire perimeter. So for that, it would be useful if we could find a way to cut our circle up into those 6 segments. And this is where the segment tool comes in handy. So this one's under Tools, Sketch Tools, Segment, or you can use the little search bar, but I always like knowing where things are in the menu. So the segment tool is a little tricky. You need to make sure that you have it set to sketch segments, because for whatever reason, the default option for the segment tool is to just draw points instead. So we set it to sketch segments, set it to 6, and then we can select our circle, and it will cut this up into arcs that are equally sized. So that already gives us these nice and easy equal length relations that connect all of the pieces together, and it gives us co-radials that make it so that they all have the same radius and they're all concentric with each other. So much easier than trying to draw that out by hand. However, that did take us from fully defined to underdefined, so now we need to do something to keep it from rotating. And for that, we can see that it looks like these panels are kind of lined up evenly with each other. We don't have any weird twisting going on. So effectively what we can do is just say, all right, one of these points is going to need to be along the same horizontal as one of the corners from our hexagon. So if we grab a point and a hexagonal corner, set them to horizontal with each other, that sets its rotation and gets us fully defined. Then from there, exit sketch, features, loft boss base, and the loft tool works best if you select a surface or an edge and then an edge, and it will then connect those two edges together. You want to make sure that you're being careful about which ones you're selecting, though, because if you're not careful, you could end up twisting it a little bit, and that looks cool but isn't exactly what we're going for here. Sometimes you can recover, but yeah, there we go. Oftentimes the easiest thing is just clear, select an edge, select the edge, and that gets it all nice and neat for us. Checkmark. Alright, so no other aspects of this are going to end up being hollow, so this is an excellent time to apply our shell feature. So we've got our shell thickness, or our wall thickness, specified in this note, is 0.2. So in our parameters, we'll plug in 0.2, set it to show preview, and then we need to decide if any surfaces need to be removed. Based on our isometric, it does look like you can see into the mug from the top, so we are going to need to select that top face here to get rid of that surface and give us sort of clean access to the inside of our object. Alright, at this point we can branch out. We can either do the notches on the top or the handle. I feel like the handle is going to be more interesting, so we'll start there. This one, we see it is visible on the front view, what the profile, or what the path is that this sweep is going to follow. So for that, I figure in the front view is where we can see it. I think I said top. This is our bottom view, this is our front view, this is our top view. But for that is on our front plane, creating a new sketch here. Then for that, we've got sort of a straight horizontal line. And then this looks a bit more like an ellipse than an arc. So we can see that we've got sort of a width of 1.1, and then we've got a height. Right, we don't actually have a height defined. We've just got a offset from the top, down one, up one, so its quote-unquote vertical diameter would end up being 3 units, whereas its horizontal radius is 1.1 unit. So this would not work as a circle, so it'll need to be an ellipse, or a partial ellipse in this case. So if we have to drop down there, we can pick the partial ellipse option, and this is going to be, it's like it's centered directly below the end point of the line. Then it goes up, then it goes over. Oops, forgot the ordering for these. Oh well. Always click drag to fix it up. Cool. You see the end of it lives directly below our center mark as well. So if you grab those two, set it to vertical. Now, vertical the top bit as well, just to be safe. And then we can start figuring out some of our other numbers nonsense. So for this one, we see that the top edge of it should be 1 unit down from the top of our object. The bottom edge should be 1 unit up from the bottom of the object. We know that the horizontal width of our ellipse is going to end up being 1.1. We know that the horizontal position of the center mark, we've got our 1.1, we've got our 1, we've got our 1, we've got this 3, or 3.3, there we go, from our origin over to our center there, 3.3, there we go, and then we're just left with this endpoint. So we have a couple of options. We can either define it to the outer edge, where it's then going to end up having a gap, or potentially giving us some errors. We could define it to the inner edge, which in this case is going to work out okay, but in more general cases might cause some problems. Or, I think what I'm going to do is turn it into a construction line, and once we've done our sweep, we can just do an extrude from there to ensure that we get nice contact with that boundary surface. Now let's start with the let's do the inside first, and then I'll do it the other way so we can see. But we need this to pass through the outside of the object, but not so far in that it sort of extrudes out too much. Actually, so I don't quite remember what the best way is to approach for this. So yeah, we'll try this, and we'll see what happens. So from there, we can exit sketch, and then see, we can do our 3.3 was used. Yep. Now that we are out of that, we can do our sweep. So swept boss base is going to be a circular profile with a diameter of 0.4 based on this dimension in our top view. Select our path there, and we can see from the profile. Oh, okay. So from the preview, there was a non-zero chance that it looked like something would show up on the inside, but it seems like that got cleaned up pretty good. So this ends up working out pretty fine. No major issues or concerns or anything, but you can imagine circumstances where this could end up with some portion of the object leaking onto the inside. For those ones, you could do an align with end faces, and that would also make sure that we keep things nice and crisp. But in the interest of trying out some other techniques, let's do the one that I was originally thinking that would be a bit more consistently reliable. So we'll set that line to construction so that it's not affecting anything anymore. And then we can do our swept boss base, circular profile for that, diameter of 0.4. There we go. Then what we can do is create a new sketch on this end surface. New sketch there. We want to convert entities. We'll just give us the boundary of that circle. And because I had that face already selected, it did it for us automatically. Otherwise, convert entities, select the face, check mark, gives us that. Then we can go features, extrude boss base, and we want to do up to next. And this one, it's important, we have it set to merge results, and it's set so that the feature scope is using all bodies. I think the default that it gives us is also pretty reliable, but there are circumstances where that can end up getting a little screwy. So making sure that we choose the intentional all bodies option is the best way to make sure that you don't end up in any weird circumstances. All right, let's wrap this up with our patterns. So let's do the one on the handle first. We see that the first little notch that we've got is 2.5 units over from the central axis, and then it goes out with a 0.3 spacing. And each one of these little cutouts looks like a partial circle. So that ends up being easiest from the front view. So that's going to end up being a sketch on the front plane. Draw in our circle. Looks like that lives right along the top edge there. We don't have anything giving us any offsets, and our center marks look like they are all nicely aligned with that, with those line segments there. So we've got our circle. Dimension this. It's got a radius of 0.1. So it's going to be a diameter of 0.2, but calculating our dimensions isn't good. So we can right-click on it afterwards and then set it to display as radius. I'm doing it as a full circle just because that's marginally easier than doing it as a half circle and then getting all of that defined. But you could also do this as just an arc horizontal line to cap it off, and then dimensions as needed. But we've got our circle, and then our horizontal position is going from the circle to the origin, and 2.5 units. Cool. Features, extruded cut. So it's going to be a through all both. Checkmark. Cool. So there's one down. Then linear pattern. And for this one, it's going to be patterned here. Well, it's usually easiest if we select the thing that we're patterning first. So we've got our little notch there. For the direction, this one's going to be sort of going left from there, so we can just pick our dimension if we would like. And it is spaced with 0.3, and there are 4 of them. So we see that the last one sort of cuts a little bit into the ellipse, or the partial ellipse that we've got. Checkmark. Cool. Well, that looks about right. Last bit are these little rectangular cutouts that we've got on our top of the object. So you can do these either from the front view, because we see it from our detail view here, or I think it's a bit more intuitive to imagine these as being cut down from the top. So for that, we're going to create a new sketch on this top face of our loft. And these, we know the position of the bottom one. So we're going to use that as our initial one, and then we can circular pattern it around to get the others. But let's see, we've got some little rectangle somewhere around here-ish. We know that it is set up so that its height is sort of measured from where the lip would be, at least from the looks of it. So for that, go for edge is going to need to be tangent to the arc. Then you know it's got a height of 0.15, so that dimension 0.15, and then a width of 0.25. And then from there, we need it to be centered within our object. Easiest way to do that, draw in a center line going from our origin to the center point of one of these lines, and then we can set that construction line to vertical, and that'll hold it right in the right spot that we need it. Features, extrude cut. This one's going to go down, looks like 0.1 unit. So we've got 0.1 plugged in as our depth. And we do not need direction 2 on this one. Cool. So there's our blind. Check mark. Guess also that was one thing I skipped over a little bit when we did the cut on this one. We wanted this so that it's set to through all both, so that it removes material both beyond the plane that we sketched it on and behind the plane that we sketched it on, and in front of the plane that we sketched it on. So you could do that as either just a through all, and then check the direction to and through all on that as well, or a through all both is a little bit more elegant. So that takes care of both of those for us. But with this one, it's just going to end up being a blind extrude cut, and we don't need anything cutting above from that reference, or from the sketch plane that we were using. Cool. So there's one. Then we need 6 more. So for that, we can use the circular pattern tool, where we want to circular pattern this feature. So we'll select that with our features and faces. And then for direction 1, we can use any circular edge. So I'll pick this in here. Oops. We don't really want to use the face because that can offset things a little bit depending on how SOLIDWORKS calculates it. I think actually if I select the face, is it going to throw... Is it actually going to work? Yeah, if I select the face itself, it ends up getting confused. But if we select the circular edge, then it handles it okay. So for this one, we're told that there are 7 of them by the little notes. Yeah, we used 2.5, we used the 0.1, we used the 0.25, we've used the 0.15. We're told there's 7 of them, and we're not given any explicit dimension telling us what their spacing is, so we can safely assume that they are going to be evenly spaced. So if we use the equal spacing option, we set that to 360 with 7 instances. Checkmark. Control 7, double check our orientation. Everything is matching up pretty good there, and I think we can probably call that good. So if you've got any questions, feel free to reach out. Otherwise, I believe this wraps up for our demonstration, and wishing you the best of luck on the quiz. Have a good one. Bye.